In Module 2, Lesson 6, we're going to shift our focus to the distance between two rational numbers. In Exercise 1, partners would be finding their own distances between related integers, and then they would discuss, and we would discuss as a group. So briefly, if we are looking at -4 and +5, the distance between the two would be 9. And remember, distance is never negative. Person B, then, finding the distance between 5 and -4, when you look on the number line, you can see that those are exactly the same integers, and so the distance between them is the same. They both have a distance of 9. Continuing on, the distance between -5 and -3 we can clearly see is 2. And likewise, the distance between -3 and -5 is also clearly 2. Finally, the distance between 7 and -1 is 8. And as we would expect, the distance between -1 and 7 is also 8. So we can see that the order of those numbers doesn't matter. Exercise 2 continues in the same manner. The distance between 0 and -8 is 8 units, because remember, the direction doesn't matter, only the distance. And then looking at rational numbers, the distance between -2 and -1 1/2 is 1/2. And finally, the distance between -6 and -10 is 4. Now we use that information to develop a formula for distance. To find the distance between -3 and 2, we would first start on -3 and then count the number of units from -3 to 2, which we find is 5. So when we graph the two numbers on the number line, starting on -3 and going to -2, we can see that it's 5 units, but mathematically the formula would be -3 minus 2, and remember, distance will always be the absolute value of that answer, so that's why we have the -3 minus 2 in between our absolute value symbols, which are straight up and down lines. Then we would change subtraction to adding it the inverse, and that would give us -3 plus -2 in the absolute value symbols. And when we solve that, we can see that -3 plus -2 having the same sign require us to add the numbers and keep the sign. And we're looking for then the absolute value of -5, which is 5. We'll do that same thing, switching the order of the numbers just to show that the distance is the same no matter which number you start with. And so switching the order of the numbers, we would start with 2 and subtract -3, and then changing our subtraction to addition. We're doing 2 plus +3, because when we change it to addition, we also have to change the number after it to its opposite or inverse. 2 plus 3 is 5, and the absolute value of 5 is 5. The distance between those two numbers is exactly the same, no matter which number you start with. It follows then that our rule, which is in the box on your workbook, for two rational numbers p and q, the distance between p and q is p minus q. And please notice it doesn't matter which order they're in. Example 2, distance is positive. The change in elevation or temperature may be positive or negative depending on whether it is increasing or decreasing, going up or down. A hiker starts hiking at the beginning of a trail at a point which is 200 feet below sea level. He hikes to a location on the trail that is 580 feet above sea level and stops for lunch. Question A is, what is the vertical distance between 200 feet below sea level and 580 feet above sea level? We would represent 200 as negative 200 since it is below sea level, but remember we're looking for distance. So the first thing we need to do is make sure that we include our problem in the absolute value symbol. So we're doing negative 200 minus 580 according to our distance formula. Which we will then change into an addition problem where we will add the inverse. So our inverse of 580 is negative 580. We are adding two integers with the same sign. So we will simply add the numbers and keep the sign. And that will give us negative 780. The absolute value of negative 780 is 780. So the vertical distance is 780 feet. Which then leads us to part B. How should we interpret the 780 feet in the context of the problem? We should say that it is 780 feet between the starting point of the trail and the place where the hiker stops for lunch. After lunch, the hiker hiked back down the trail from the point of elevation, which is 580 feet above sea level, to the beginning of the trail, which is 200 feet below sea level. 580 above sea level, which is our location. So we've labeled our vertical number line with 580 feet above sea level and 200 feet below sea level, which would be negative 200. And then we're asked what is the vertical distance between 580 feet above sea level and 200 feet below sea level. So we would use the distance formula. 580 minus negative 200. Change that to addition. 580 plus 200. And the answer would be the absolute value of 780, which equals 780. So our change in elevation is 780 feet. Exercise 3. The distance between a negative number and a positive number is 12 1/2. What are the numbers? This problem allows for quite a bit of flexibility. Because all we're really looking for are two numbers, one that is negative and one that is positive, whose distance between them is 12 1/2. I will make one suggestion, but there are many, remember. First of all, we might say the distance between 3 and -9 1/2 which using our distance formula would be 3 plus 9 1/2 which is the absolute value of 12 1/2, which is 12 1/2. Again, this is one suggestion, but there are many, many combinations that will get you there. So finally, in exercise 4, we're going to use the distance formula for each answer, and you are asked to support your answer using the number line diagram. The distance between -7 and -4 would be the absolute value of -7 minus -4. Which is the absolute value of -7 plus 4, since we have to add the inverse. And since those two numbers have the opposite sign, we would have to subtract their absolute values and keep the sign of the greater absolute value. -7 is the greater in magnitude of the two numbers. So our answer is actually going to be -3. And the absolute value of -3 is 3. In part B, find the change in temperature if the temperature rises from -18 degrees Fahrenheit to 15 degrees Fahrenheit. And in this example, you'll draw a vertical number line. But mathematically, we are looking at -18 minus 15. And the absolute value, we're going to change this to an addition problem, and we will add the inverse, which is -15. Since the two numbers have the same sign, we will add their absolute values and keep the sign, which will give us -33, and the absolute value of -33 is 33. So the change in temperature when the temperature rises from -18 degrees Fahrenheit to 15 degrees Fahrenheit was 33 degrees. Question C, would your answer for part B be different if the temperature dropped from 15 degrees Fahrenheit to -18 degrees Fahrenheit? The question in part B was to find the change in temperature. And if we answer that the temperature has increased 33 degrees in part B, then in part C, we might say that it is decreased 33 degrees. But the change is the same, 33 degrees. Part D. Beryl is the first person to finish a 5K race and is standing 15 feet beyond the finish line. Another runner, Jeremy, is currently trying to finish the race and has approximately 14 feet before he finishes the finish line. What is the minimum possible distance between Beryl and Jeremy? Again, this is a distance problem, so we'll set it up with Beryl, who is 15 feet beyond the finish line, And so in setting up our problem, Beryl, who is standing 15 feet beyond the finish line, would be a positive 15 because he has finished and is that much further, where Jeremy has 14 feet before he reaches the finish line is a negative 14. Using the distance formula, we then set it up as 15 minus negative 14, and then we'll continue with the formula, changing it to addition. 15 plus 14, since we have to add the inverse. Both numbers have the same sign, so we will add their absolute values and keep the sign, and the absolute value of 29 is 29. Why does the question ask what is the minimum possible distance between Beryl and Jeremy? Because when they described where Jeremy was, it said he has approximately 14 feet before he reaches the finish line. So it's not an exact, and that's why they're asking the minimum possible distance. Finally, part E. Ask what the change in elevation from 140 feet above sea level to 40 feet below sea level is. So we'll start with 140. And subtract 40 feet below sea level, which is negative 40. Again, changing to addition and adding the inverse, which would be positive 40. And we're looking for the absolute value of 180, which is 180 feet. Remember to look over the lesson summary and make sure that it makes sense to you, and then continue on with the problem set.